For decades, scientists believed the universe was vast, but ultimately measurable, about 14 billion light-years in every direction, a few 100 billion galaxies. Enormous, yes, but still something the human mind could wrap itself around. Then James Webb turned on its cameras. Almost immediately, that comfortable picture began to fall apart. Webb didn't just see farther, it revealed an observable universe, nearly 93 billion light-years across, packed with galaxies hiding in regions that once looked completely empty. It detected fully formed galaxies just a few 100 million years after the Big Bang, black holes growing at impossible speeds, and structures that seemed far too large for their age. But the most disturbing discovery isn't how far Webb can see. It's what these discoveries imply about how much of the universe we will never be able to see. If you're ready to question everything you thought you knew about reality, hit like, subscribe, and let's begin. Welcome back to Beyond Space. Where we explore the universe one mind-blowing idea at a time. To understand what James Webb is truly revealing, we need to let go of a simple idea. That space is something we just look across. In the universe, distance and time are the same thing. Light does not arrive instantly. It travels at a fixed speed, about 186,000 miles per second, fast enough to circle Earth multiple times in a single second. But even at that speed, distance creates delay. When you look at the moon, you see it as it was 8 seconds ago. The sun appears as it was 8 minutes ago. The nearest star appears as it existed over 4 years in the past. These delays are small, until they aren't. Look toward the center of our galaxy, and you're seeing light that left 26,000 years ago. Look beyond the Milky Way, and you're no longer seeing the universe as it is. You're seeing earlier chapters of a story already billions of years old. The night sky is not a snapshot, it's an archive. James Webb was built to read the oldest pages of that archive, not by looking for brighter objects, but by detecting light that has been stretched by the expansion of the universe itself. As space expands, it stretches the light traveling through it. Wavelengths grow longer. Blue and ultraviolet light shifts into red, then into infrared. The farther the light has traveled, the more stretched it becomes. This stretching, called redshift, turns light into a cosmic timestamp. Earlier telescopes like Hubble were optimized for visible light. That made them powerful, but limited. The farther back astronomers tried to look, the more ancient galaxies slipped out of view. They weren't gone. Their light had simply moved beyond what we could see. James Webb was designed for that missing light. Its gold-coated mirror and ultra-cold operating environment allow it to detect photons that have been traveling for more than 13 billion years. When Webb stares into what looks like pure darkness, it isn't seeing emptiness, it's waiting. And what it found there shocked astronomers. Galaxies already existed when the universe was only 300 million years old, less than 3% of its current age. To put that in perspective, if the universe's entire history were compressed into a single year, these galaxies would appear on January 2nd. According to long-standing models, this era should have been dim and quiet. Small, fragile galaxies slowly assembling. Large, structured systems weren't supposed to exist yet. But Webb found galaxies that were already massive, already bright, already forming stars at intense rates. That brightness matters. Bright galaxies require huge numbers of stars. Stars produce heavy elements like carbon and oxygen, and those elements only exist after earlier stars have lived and died. Which means the universe didn't ease into complexity, it rushed. And there's something deeply humbling about how we detect this ancient light. Webb often stares at a single patch of sky for hours or days, collecting photons one at a time. Each photon began its journey before Earth existed, before the sun formed, before the Milky Way fully assembled. By the time that light reaches Webb, it isn't showing us what's happening now. It's showing us something that happened once, and will never happen again. This is why astronomers say Webb doesn't just look far away. It looks backward in time. But even Webb has a limit. There is a boundary no telescope can cross, defined not by technology, but by physics itself. It's called the observable universe. A vast sphere centered on us with a radius of about 46.5 billion light-years. Beyond that boundary, light hasn't had enough time to reach us, and never will. And here's the unsettling part. Space does not end at the edge of what we can observe. Beyond our cosmic horizon, galaxies still exist. Stars still form. Black holes still merge. Entire cosmic histories unfold forever hidden from us. Not because we lack the technology, but because space itself is expanding too fast. James Webb hasn't just shown us what we can see. It has shown us how much is permanently unreachable. And then Webb did something even more disturbing. It started counting galaxies. For decades, astronomers estimated the universe contained a few 100 billion galaxies. That number came from deep Hubble images, tiny patches of sky packed with thousands of galaxies, scaled up to the full sky. It was already an astonishing number. It was also wrong. When Webb revisited those same regions, darkness turned into structure. Empty space filled with faint infrared glows. Smudges became galaxies. In one deep field image, Webb detected nearly 800,000 galaxies in a region of sky most people would dismiss as empty. Every point of light wasn't a star. It was a galaxy, each containing millions or billions of stars. This suggests the observable universe may contain trillions of galaxies, not hundreds of billions. The universe isn't sparsely populated islands in darkness. It's crowded, layered, alive at every scale. And these galaxies aren't scattered randomly. They trace vast filaments stretching across space, intersecting at dense nodes and avoiding enormous voids. The universe resembles a cosmic web, an invisible structure shaped by gravity and dark matter, with galaxies flowing along filaments like traffic on cosmic highways. Webb has shown that this structure existed surprisingly early. Some filaments span millions of light years when the universe was only a few billion years old. Structure formed fast, too fast, and that creates a problem. Because according to our models, gravity shouldn't have had enough time to build all of this. This is known as the too much too early problem. Galaxies were brighter, more massive, and more chemically evolved than they should have been. Black holes weighing billions of suns already existed when the universe was less than 500 million years old. By conventional physics, they shouldn't be there. Something accelerated cosmic evolution. Whether that means star formation was more efficient, black holes formed differently, or our models are incomplete, something is missing. And then there's the final twist. Even this vast, crowded universe is only the part we can see. The observable universe isn't 13.8 billion light-years across. It's 93 billion light-years wide. Not because light traveled faster than light, but because space itself expanded while the light was traveling. When ancient galaxies emitted the light we detect today, they were much closer. Over billions of years, space stretched beneath that light like a moving walkway. Some regions expanded so fast that their light will never reach us. And that boundary is still growing. At the same time, expansion is accelerating, driven by dark energy. Galaxies we can see today will eventually slip beyond the cosmic horizon. Their light will stretch, fade, and vanish forever. Future observers may see a universe containing only their local group of galaxies, surrounded by darkness. They may never know the wider cosmos ever existed. James Webb has made this reality impossible to ignore. The observable universe is not the universe. It's just what happens to be visible from where we stand, right now. Beyond it, reality continues, unseen, unreachable. James Webb didn't just reveal how big the universe is, it revealed how small our window has always been. If you enjoyed this journey through the true scale of the cosmos, like the video, subscribe to Beyond Space, and leave a comment below. What do you think lies beyond our cosmic horizon? The universe is vast, but its greatest mystery is how much of it we'll never see.